The Human Genome Project was an international research effort to determine the sequence of the human genome and identify the genes that it contains. The project was coordinated by the National Institutes of Health and the U.S. Department of Energy. Additional contributors included universities across the United States and international parties in the United Kingdom, France, Germany, Japan, and China. The Human Genome Project formally began in 1990 and was completed in 2003, 2 years ahead of its original schedule. The work of the Human Genome Project has allowed researchers to begin to understand the blueprint for building a person. As researchers learn more about the functions of genes and proteins, this knowledge will have a major impact in the fields of medicine, biotechnology, and the life sciences.
Throughout the years, genetic engineering has evolved from breeding parents with desired genes for their offspring to contain to selecting a desired gene and inducing it in other organisms. With this advance in genetic engineering, we are one step closer to completely controlling how new generations look, behave, their athletic ability, and their health. Before specific gene manipulation, farmers would breed plants and animals for desirable traits together. For example, a farmer could breed a muscular bull with a cow with good mothering abilities. If the offspring was a cow, then it would be a strong female with great mothering abilities. Then that offspring would be bred for cows with good desirable traits and for strong bulls that can pass the good mothering trait to their offspring.
A benefit of the Human Genome Project in knowing your genetic code is knowing which preventable diseases, or diseases you can lessen the chance of, you might have during your lifetime. For example, if you find out that you have a high chance of breast cancer, you can take the precaution of a double mastectomy. A problem with this is knowing what unpreventable diseases you might have during your lifetime. Knowing that you're going to get Alzheimer's or Huntington's disease can be mentally destructive and can cause serious psychological problems. Another main ethical issue with the Human Genome Project is having your genetic code available for the public. If you have a higher chance of getting a certain disease, people could go and find it and judge you accordingly. An employer might not give you a job because you might need to leave work due to an illness. A potential date might look up your genetic code and see something they don't like, so they don't go out with you.
Ethical issues of genetic engineering is the experimentation, morality, and economy. There would be an idea of beauty as perfection, causing there to be no perfection because everyone is their parents' idea of perfect. If everyone has alterations in their genetics, most people's athletic abilities would be the same along with their intelligence. If everyone is equally as athletic and smart, it's harder for the job economy. There would be too much competition for one job. Unless they had a desire for a less formal job, they would have a difficulty getting the job everyone else can qualify for. The experimentation can have unhealthy downsides and dramatic alterations not meant to be made. People can die or get drastically ill, taking a toll on their health. The problem with the morality is that these people wouldn't be the way they are by heredity. They would be the way their parents want them to be. These people are in the vision of society rather than being in the vision of humanity's natural state.
Knowing your genetic code and what diseases you might have during your lifetime has benefits and concerns. Knowing which diseases you have a high chance of getting can cause you to take extra precautions to lower your risks of getting that disease. The problem with this is knowing which diseases you have a small chance of getting, and that can cause a person to not take any precautions involving that disease. For example, if you see that you have a small chance of obesity or heart attack, you might not eat very healthy or not exercise often, raising your risks of that disease.
One benefit is dramatically increased health, like in the case of Ashanti Da Silva. She had adenosine deaminase deficiency. Doctors removed all her T cells and replaced them with mutated white blood cells. The cells did, in fact, produce typical ADA. Her immune system improved and she is now healthy. One concern is declined health and/or death. In 1999, a modified cold virus was used to insert a corrective gene into a man's DNA. The modified virus caused an unusual but deadly immune response in him. He had multiple organ failures before he died. Between both the benefit and the concern, there is a wide range of health complications. They could be minor to needing a few shots now and then to dying from your treatment. Not many people would take the risk unless they were like Ashanti. She could have died anyway if her gene therapy had failed.
Not many people have gotten their DNA coded, but a select few have. Some of these people's genes have been used to learn more about diseases that were previously unknown to scientists. In the future, even more can be learned about these confusing diseases. No one that we know has really been affected by the Human Genome Project, but in the future, when coding DNA becomes cheaper and more popular, we're sure to be affected by it. Knowing your genetic code is everyone's choice, so people should be able to decide if they want to know their DNA, and if so, what parts of it. A law should be passed to protect people's DNA privacy. This way, companies and people wouldn't be able to discriminate against a person's genes.
I believe this should still be studied and tested, but control the environment and what changes are made to the subjects of genetic therapy and gene inducements. Scientists should still only be testing minor changes in one's genetics. We could cure every disease we encounter in our lifetimes, maybe even extend our lifespan. But if we don't research further, we can still make mistakes, possibly killing hundreds of test subjects before we get genetic engineering right. It needs to be 100% successful before it's open to the general population. Therefore, there won't be accidents or lawsuits or all those issues that society just somehow comes up with. But the day that happens, we enter the age of near perfect beings.